Hi, welcome to our math. Today I'm doing a series of videos on exponential functions, and in this video we're going to talk about graphing them. There are some tricks to the trade, but I find it's just simpler to plot a few points and go. So if I was going to plot this, let's see, 0.5 to the negative 2 is equal to 4. 0.5 to the negative 1. If you're wondering how I got that so fast, 0.5 is 1/2. And negative 1, that negative means reciprocal, so that's 2 to the 1, whereas this was 2 squared. Anything to the power of 0 is 1. 0.5 to the 1 is 0.5, and 0.5 squared is 0.25. Then I graph them. Negative 2, 4. Negative 1, 2. 0, 1. 1/2 and 1/4. This side comes up nicely with an arrow. This side decays with an arrow. A couple of things. When I'm grading these, if there's no arrows, you lose a point. It can never cross. This x-axis is an asymptote. It is a barrier that the graph doesn't cross. So you have to show that it's getting closer without touching it or crossing it. And this side, you need it to be a nice smooth graph showing growth. All right, for my next one, it's going to have a lot of the same components. Let's see, 3 to the negative 2. Well, that's the same as 1/3 squared, so that's 1/9. Let's see, 3 to the negative 1 is the same as 1/3 to the first, so that's 1/3. Anything to the power of 0 is 1. 3 to the first is 3. 3 squared is 9. I want you to look at these two tables. I want you to notice 0.5 is the same as 1/2. 0.25 is the same as 1/4. 4, 1/4. 2, 1/2, 1. 1/9, 9, 1/3, 3, 1. This is not 100% of the time when you graph exponentials. Nothing is 100%. But for the really basic graphs, this is very common, having this kind of setup. Which means if you have to graph this without a calculator, if you remember this pattern, this type of output, it makes it easier when you're graphing. All right, so this one was 0.5. It's decay because our factor is less than 1. Here our factor is 3. We have negative 2, 1/9, negative 1, 1/3, 0, 1, 1, 3, and 2. Hey, I have 2, 9 on the graph. So when I graph this, I try to do a smooth growth side, a smooth decay, and again, we have our asymptote. Again, we have to make sure that this is a smooth graph that doesn't cross the x-axis. We have arrows, and it all looks very good. All right, I hope you've enjoyed this video. Please subscribe to my YouTube channel, like my Facebook page, and I'll see you on the next video. Thanks.